Far beyond the familiar worlds of our solar system, two aging spacecraft continue an extraordinary journey through a region no human had ever explored before. Voyager 1 and Voyager 2 left Earth in 1977, during a rare planetary arrangement that allowed them to use the gravity of the giant planets to accelerate from one world to another. Voyager 2 completed an incredible tour of Jupiter, Saturn, Uranus, and Neptune. Voyager 1 focused on Jupiter and Saturn before taking a trajectory that carried it toward the outer reaches of the solar system. Neither spacecraft was originally expected to remain scientifically useful for so long. Their power comes from radioisotope generators containing plutonium-238. As that material slowly decays, the available electrical power decreases. Engineers have therefore spent decades shutting down unnecessary systems and carefully managing every remaining watt. The mission faced one of its most serious challenges in 2023, when Voyager 1 began transmitting data that engineers could not properly interpret. Instead of useful information, the spacecraft repeatedly sent an unintelligible pattern. The problem was eventually traced to corrupted memory within the flight data system. Repairing a spacecraft more than 20 billion kilometers from Earth is not like fixing a computer in a laboratory. A command can take many hours to travel to Voyager, and engineers must wait again for the spacecraft's response. Yet NASA's team developed a workaround, rearranging software functions and moving critical information to healthier sections of memory. The effort worked. Voyager 1 began returning usable engineering information again, demonstrating that a machine launched nearly half a century ago could still respond to carefully designed instructions from Earth. But the most important discoveries came when the spacecraft approached the boundary of the Sun's enormous protective environment. The Sun constantly releases a stream of charged particles called the solar wind. This wind expands outward and creates the heliosphere, an enormous bubble surrounding the planets. Inside this region, the solar wind and magnetic field influence the environment through which Earth and the other planets travel. Eventually, Voyager encountered the outer boundary of this bubble. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. Their measurements showed that the transition between solar and interstellar space was far more complicated than scientists had once imagined. Instead of simply fading into an empty vacuum, the region near the heliopause contains changes in particle density, magnetic fields, and energetic radiation. Voyager 2's measurements were particularly valuable because it crossed the boundary along a different path. Together, the two spacecraft provided scientists with two separate windows into the same enormous frontier. The discoveries suggested that the heliosphere is not a perfectly smooth shell. Its shape and boundaries are influenced by the interaction between the solar wind and the surrounding interstellar environment. Beyond that boundary lies the interstellar medium, the material between stars. It may appear empty from a human perspective, but Voyager's instruments have shown that this region contains charged particles, magnetic fields, cosmic rays, and waves. And perhaps most surprisingly, the space between stars is not completely silent. Voyager's plasma wave instrument has detected oscillations traveling through the surrounding plasma. These measurements allow scientists to estimate properties of the interstellar environment even when no conventional atmosphere exists. The spacecraft have therefore transformed an invisible region into something measurable. Every particle detected, every magnetic fluctuation recorded, and every plasma wave observed adds another piece to our understanding of the space separating stars. Yet Voyager's journey is far from finished. As these spacecraft continue moving outward, they are entering an environment that no other human-made machine has explored from such a distance. And what they discover next may reveal just how complex the space between stars really is. Voyager's greatest achievement may not be the photographs of distant planets captured during its early mission. Its most remarkable contribution could be what these spacecraft have taught us about the enormous region beyond the Sun's influence. Once Voyager crossed the heliopause, scientists expected to encounter an extremely sparse environment. Instead, the spacecraft detected measurable changes in plasma density and magnetic conditions. Voyager 1's plasma wave instrument has repeatedly detected signals associated with the surrounding interstellar plasma. These aren't sounds traveling through space in the ordinary sense. They are electrical and plasma oscillations that scientists can measure with instruments aboard the spacecraft. That distinction is important. Human ears cannot hear the vacuum of interstellar space. But charged particles can interact with electromagnetic fields and generate waves. By studying those waves, researchers can learn about the density and behavior of materials surrounding Voyager. In this way, the spacecraft acts almost like a remote scientific probe embedded inside the interstellar medium. The measurements also reveal that the boundary of the heliosphere is an active region. Solar eruptions can send enormous disturbances outward from the Sun. When these disturbances eventually reach the distant outer heliosphere, they interact with the surrounding plasma and create measurable effects. Voyager can detect some of these disturbances even after traveling far beyond the planets. The spacecraft's instruments also continue studying energetic particles known as cosmic rays. These particles originate from powerful astrophysical sources and can travel enormous distances through the galaxy. Magnetic fields influence their movement, sometimes changing the paths they take through space. Understanding these fields is important because they help determine how radiation travels through the galaxy. That knowledge could eventually become valuable for future human missions beyond the solar system. A spacecraft traveling toward another star would face a very different radiation environment from anything experienced near Earth. Mapping magnetic fields and energetic particles could help scientists understand where radiation is concentrated and how it moves through interstellar space. Voyager is also helping researchers understand our neighborhood within the Milky Way. The Sun does not exist in isolation. Our solar system is moving through a larger galactic environment containing thin clouds of gas, dust, magnetic fields, and energetic particles. Nearby stellar explosions in the distant past may have altered this environment, leaving behind structures that still influence the region today. Voyager cannot create a complete map of this enormous territory by itself. However, its direct measurements provide ground truth for scientists building broader models of the local interstellar medium. The spacecraft are essentially sampling the environment from inside it. There is another remarkable aspect of Voyager's mission. Attached to Voyager 1 and Voyager 2 is the famous Golden Record, created as a symbolic message from Earth. It contains sounds, music, images, and greetings intended for any distant civilization that might someday encounter the spacecraft. Whether anyone ever finds it is unknown. But the record represents something larger than communication. It is a statement that humanity chose to send a small piece of its existence beyond its own planetary neighborhood. Voyager 1 is now traveling through interstellar space at an extraordinary speed. Yet the spacecraft's future is limited by its declining power supply. Engineers must continue turning off instruments and reducing energy consumption to keep the mission alive for as long as possible. Eventually, the remaining systems will shut down. The spacecraft will then become silent, but its journey will continue. Voyager 1 will keep moving through the Milky Way long after its electronics stop responding. Its trajectory will carry this small human artifact through the galaxy for an unimaginably long time. The true legacy of Voyager is therefore not simply that humanity reached another planet. It is that two machines built on Earth crossed the boundary of the Sun's domain and began directly measuring the environment between stars. They showed us that interstellar space is not simply an empty black void. It contains particles, fields, waves, radiation, and structure. And somewhere beyond the fading signals of these ancient spacecraft lies a much larger frontier, one that humanity has only just begun to explore.